I messed up the data of the salary here because I had, what did we do wrong here? Because I had too many commas. There we go. Okay, now we're looking good. Median should have been 53,000. And then here is the new the mean and median without Newman's salary. So there's the mean, median. You all with me on this? So it really should be, this should really be 53,000. And then when we remove his salary, it's 52,500. So we'll say no Newman, with Newman. So the point you're supposed to see here is when we remove that really large salary, it has almost no effect on the median, which tells us that the median is a really good measurement of average or central tendency. So we got almost no difference. Which then leads us to a really important concept. Outliers are sample data values that are very far away from the majority of the data values. So Newman's salary is an outlier, and technically so is, or most likely so is George's. That 20,000 is pretty far away from all the other data values, like not nearly as far away as Newman's. Newman's is way, way, way far away, but even George's is like a 30,000 difference between a bunch of the other salaries. So what happens is what we say is median. Let's say it this way: the median is resistant to outliers. So this then leads to a really important concept in statistics. If there are outliers, so if our data set contains outliers, the median is the best measure of average. And I'm going to call it center this time instead of average. And then if there are no outliers, report the median or the mean. Okay. Key concept to put down. There's one last measurement here, and that is the mid-range. And it's a very quick calculation. And what it is it's the maximum, it's the mean of the maximum and the minimum. So the mid-range, I gotta teach my class. The mid-range is equal to the maximum plus the minimum divided by 2. And we can do this calculation in Desmos, because Desmos uses maximums and minimums, or has a maximum and minimum feature. So we could just do max of A, and it spits out the 944,000. And then we can do minimum of A, and it's I add it together. If I cut this out, it gives us the 20,000. And then we just divide that mess by 2, and this would be the mid-range, 482,000. That is a measure of average. It's a really, really bad measure of average because it uses only outliers in its calculation. But it's a super fast one. So if you have a ton of data values and you know the maximum, minimum, it can give you just a rough idea of where the center could be. I don't know. To me, that's a rough argument. Okay, so what we're saying here uses outliers exclusively in its calculation. Okay, so I want you to try this before we go on to the next piece in this. So grab your worksheets, and I want you to answer. We're doing page this one, and we can ignore, for now, ignore the stem and leaf plot stuff, and just get the median, the mean, and the mid-range. Get those three things out of StatCrunch, out of Desmos for these values. So let me give you 5 minutes to try that. It's a little annoying because you got to type them into Desmos. But that's part of the game, I guess. Set a timer for 5 minutes. And here, I'll give you all this link that I'll dump this list. If I made a mistake, fix it. But there, I typed it in for you, so that should save you some time. So maybe we don't need 5 minutes. Tell me when you've got your answers. Okay, do y'all agree with my answers? Of course, if you used the same data set as me, then you would definitely agree with them. So 21,000, oops. I need 2 monitors. All right. So I'm getting the mean is 21, is 21,050.05 million. The median 21,769.50 million. And the mid-range is 2264 million. And the reason I say million is because if you read the context, these are in millions. This is the same data set you used in your Unit 2 project that I finally graded this weekend. Okay, so questions on that? Now, this question is a screw up. What is the average score? This was an old question. We should say, what is the average federal outlay? Let's see, what is this? For the Department of Justice. What is the average spending? The Department of Justice. But let's first go figure out what mode is. For this question to make sense, right? Okay, so jumping back to our lesson here, I don't need this open. What is this here for? So the last measurement is mode, and it's just the number that is most repeated. And it is also a measurement of average. And you just look at the numbers and figure out which number occurs most often. So when we're looking here at these, at this data set, we've got 12 occurring 1, 2, 3, 4, 5, 6, 7 times. I think that's the mode, but let me just double check because it looks like 15 shows up a bunch. So I got 1, 2, 3, 4, 5, 6. Okay, so 15 was a close second. 12 is the mode. We could calculate the mean, and it's going to be similar. If you think about what's happening here, the mean adds up the data values and divides by how many. So the mean and the mode might be close, especially because if you look at this particular data set, there aren't any outliers in it. So they will be close. What really turns out here is mode is the only measure of average, only measure of center for categorical data. Because it's not a calculation, it's just a frequency count. So if we skip down to this question, here our data set is a list of majors for students. So the mode, and if you look here, the mode is business because it occurs 1,425 times. And that's really the only time we use mode as a measurement of average is when we're working with the categorical data set. It's the most often. All right, so let's put this all together. What are our measures of average? There are 4 of them. And let me name it measures of central tendency. The most important ones are the mean and the median. If there are no outliers, we use the mean. If there are outliers, we use the median as the best measure of central tendency. And then the two kind of, the super garbage one is the mid-range. And then the other one is the mode that we just looked at for categorical. Does everyone remember what a categorical variable is? So let's go back to our worksheet problem. Is there a mode in this data set? And so you're looking for a repeat. It would be super nice if Desmos did modes. It doesn't. StatCrunch will do it. StatCrunch. Excel will do modes for us. So that's helpful when we do our project. And I'm going to show you how to do that in a second. But in terms of Desmos, it won't. If you look at this, there are no repeated data values. So that means there is no mode. And none of these should say score. These should all say, they should all say spending. So what's the best measure of average here? If we look at our data set, we have a difference between the two of 31,000 and 9,000. That's kind of spread out. But if you look at the median and mean, those numbers are pretty close together, which suggests that even though 31,000 is fairly far away from 9,000, they're not really outliers when compared to the rest of the data values. So what the best measure of average here would be the mean, because there are no outliers. I would also accept median because there are outliers, but I would expect you to state what numbers you thought were outliers. And for our purposes in this class, like you're just kind of using a judgment call of what does it mean to be far away? And if you take our stats class, there's a very clear definition of what far away means. Okay, any questions on that? All right, we got one more topic to look at, and that's the calculation of what's called a weighted average. Oh, I didn't let you ask questions. So I'm going to jump down to this. We're going to do what's called a weighted mean, but instead of using the problem here in the book, I'm going to use our own data. So I'm going to pull up our syllabus. And what I'm going to teach you to do is how to calculate your grade, which is a weighted mean. And this is how any of your grades at Jackson College would be calculated. So this is a really super useful skill. Okay, so the first thing you do with any course, right, when you get your syllabus is you go look at the grading criteria, how the grade is calculated, and that is your weighted mean stuff. So this is the grading criteria for this class. We have these different categories. One thing that's a little bit different in the computer, instead of separating each project as 12.5%, I group these all together as 50%. So projects, all projects added together equal 50%. There we go. So, oops, so right here, this is 50%. So I'm going to just kind of do this in a new document, and we'll do, so class participation is 0.06. Alex, which is that online grade that y'all are working on, is 0.12. We got the worksheets. Those are the ones we're working on. That's also 12% of your grade. We got your projects. That's 50% of your grade. And then we've got the midterm / final. Cumulative, they're 20% of your grade. So what happens is you have assignments that pop into each of these. So for our class, the class participation are the lesson checks. Those are those little quizzes we keep doing. Presumably, you all should get 100% on those because I tell you the answers. All you have to do is bother to write down the answer I tell you. I mean, we do them in class. I even bother to tell it to you. So this should be 100%. So we'll put that in as 100. Alex, that's tedious, right? That takes some time. So let's call that like a 90%. I mean, presumably you could get 100, but it's a significant time investment. Worksheets, this should probably be 100% for you all as well. We've been doing all of the problems in class together. I think in some of the early days, if no one asked, you didn't have them all done, but I was always willing if someone asked. Projects, this one may not be 100%. Let's put this as an 80. From what I've graded, like project 2, it was pretty clear some people had no idea what I was asking them to do on it, and I felt like maybe that's because they weren't watching the videos or something. Those of you that have been attending and asking questions clearly knew exactly what was expected in the projects. So there's some wild variance in project 2, and then I've got to get project 3 graded, right? Like that's definitely on me. And then the midterm and final, I don't know. Let's just say you get like an 85. A student gets an 85. So the question is, what's the final grade going to be, and how do we calculate it? Well, what you do is you just multiply the weight times the grade you got in there, and then you add it all up. So we can do this in Desmos, but it's actually better done in Excel. Because I can type in my numbers here. And then I can do this formula that just says this times this. Drag them all together, and then type in my sum function. I'm assuming you all remember this since we've done this a fair amount from before. And this student would have received an 85.8 based on the grading scenario we have listed here. So what would their final grade be? Here is how the grade is then entered into Jetstream, because an 85.8 falls between the 85 and 89 class, you would end up with a 3.5. All right, so I want to see you all do this, but we've got some challenges. So jump to your worksheet, and if you look at what I did, I copied in this grading policy. And your job is to go look up your current grades in Jetstream for each of these. So what we can do is you don't have a grade for the project 3. You don't have a grade for a project 4. You should have a midterm exam grade, although I didn't grade the retakes yet. But you can use that midterm grade. You don't have a final grade, so you can leave that blank. You can just use the midterm grade for this. Put in your percentages for each of these categories and calculate what your grade should be. It's going to be very different than what is in the computer right now, because the computer has all of these projects lumped into a 50% category. This will lump them back out. All right, so I'm going to give you 5 minutes to try this. Do you all think you can do it? Do you think you know what's going on? Okay. Let me give you 5 minutes. You all tell me when you're done. Set a timer for 5 minutes. All right, that was 5 minutes. How y'all doing?
I'm having trouble figuring out how to get the percentage for each one because I can see each like worksheets grade, but I don't know how to see the
Hmm.
percentage for each one.
Okay, let me stop sharing because I'll end up sharing everyone's grades like I did at the beginning. And that is illegal. I think if you scroll all, well, let me see. Let me go under student view and see if I can see what you all see. Okay. Oh, here we go. So there's a nice little spot. Um, that shows this. So what you want to do, here I went to grades and you can see like I just have missing and zeros for everything. So what if you scroll all the way to the bottom, you'll see the percentage out of each assignment. And also on the right, you have the assignments are weighted by group, and you can see, well, this is the group weighting. Ooh, looks like I have Alex homework in there twice. So even for this particular class, I have things set up bad. So what you need to do is you need to find your unit 1 project grade. You want that percentage, and your unit 2 project grade. You want that percentage. You want your midterm grade, that percentage. And then let's see, well, actually, so you can do it, you could, yeah, you want those separate project grades, and then you can just take your final exam. You could take this percentage right here. Does that make sense? It's not helpful because I don't have any grades in mine. They're all non-existent. But so you would take whatever this grade is for class participation would go here. Your Alex grades you don't have, so you're going to leave that blank. If you want to type it in, you could do your however many objectives you have divided by 165. Hang on real quick. Okay, sorry. If you wanted to put that in, but your worksheet grades you have here, for me, it's 100. And then you need to go find your 2 project grades and then whatever your midterm final exam grade is. So the way this is working is you're not doing points, you're doing the percentages for each of these. You're right, Jennifer, that your points are not going to be, your points are going to be a little weird, but if you do it as percentages, it will work out. It should work out. Is that helpful or no?
I think so. Yeah, I'm putting my project scores in right now, but I
Okay.
don't know exactly how to get the percentage for the worksheets. I mean, I could do them like each individual one.
Should be at the very bottom, should just be a total percentage like this. Does that make sense? When you scroll all the way down, you should, because this is giving you the percentage for each category. And
Okay, I see that now.
you got it. Nice. Nice. And it may end up being lower than what is in there. It may be higher. It just kind of depends on if you have missing things or not missing things, or kind of what I've graded and not graded, that kind of stuff. Um, so for 10, you're going to have to predict a score for 3 and 4 because I'm so far behind in grading. Right, so you're going to do another 0.25 here, another 0.25 here, and sorry if I'm like rushing you. Don't get rushed. I'm just for those that are who've already got their calculation for 9. For here, you're going to make a guess at what you're going to get for these two. And then you can break apart this midterm and final exam percentage to be 0.10 for the midterm, 0.10 for the final. And you can put in the current grade for your midterm here, and then you can make a guess for a 0 and 100% for the final. And those would be the prediction of your highest and lowest grade for the course, or your lowest weighted average. Um, so a great question. The question is, should we be using Desmos? I would do this in Excel, actually. You could take this thing. Let's see, how you would set it up is, here's your class participation, which actually you don't know. Yeah, you do know that one. We don't know Alex, so we'll leave that blank, or you could do Alex if you wanted. Here's the worksheets, project 1, project 2, project 3, project 4, midterm exam, final exam. Put those all in to Excel, and then put in your grades here, and then do your sum of this. And this time you would need to, let's see, as long as you had grades for all of this, you should be good. If you leave out Alex, like if you delete this, you would need to do the sum of these divided by the sum of these, because this doesn't add up to 1. Oops. So if I had 100% class participation, if I had a worksheet should be 100, project 1 should be 100, project 2 70, project 3 80, project 4 90, project 5 or 70, and the final 65. So let's see, why is this coming out so bad? What is this sum equal to? Oh, my bad. I'm forgetting to multiply. That's what I'm forgetting to do. So it's this times this. And then it's the sum of these divided by this sum, because this doesn't add up to 1. There we go. Is that helpful? Nice. Yeah. Excel is the much simpler way to put it together. Yeah, so for question 9, you're just taking what's in the grade book and calculating it based on what's in there. And you should have something for class participation. So you should have something for this. You don't have anything for this in the grade book because that's separate in a separate thing. You do have something for the worksheet. You do have a grade for project 1. You do have a grade for project 2. You also have a grade for the midterm. So that's how you would calculate question 9. And then for question 10, I'm saying make a prediction for projects 3 and 4. And then for 11, you're putting in a grade for the midterm for the final as 0 for one grade, which would be your lowest grade you could get, and 100 for the other grade. So you're doing two grade calculations for 10. So the final equal to 0% would be the lowest possible grade. The final equal to 100% would be the highest possible grade. So how that would look in Excel is, let's see, this is the midterm here, and this is the final. So you do a calculation with a 0, I could get a 76. You could do a calculation with 100, I could get an 88.07. So that's the maximum grade based on these criteria. That's the minimum grade based on these criteria. Which is a way to see what happens if you don't take the final, right? And if you want, you could also toss in just for your purposes, like your Alex grade. So let's say you got 120 objectives out of 165. That's how your Alex grade would go. And you can see that I would be failing the class if I only got 120 objectives. In other words, 72% of the objectives in Alex and got a 0 on the final exam. If I got 100, I'd still pass. Is that helpful, y'all, or is that getting worse? You're all going to have wildly different answers, by the way, because this is all based on your, like this. These numbers are not going to match mine at all. Let me give you like 5 more minutes to mess with this, and then we're going to move on to 4-6. I want you to ask some questions too, but we're going to look at the measures of variation, just so we've covered, we'll have covered it all. Set a timer for 5 minutes.
So I just typed everything in. What do I do after that?
So let's see. Let me make sure I've got things labeled. So this is the weights. This is the grades, right? So you need the weight times grades category. So you just hit your equal and you select the weights, which is, these numbers from in here, times what, whoops, So it's the asterisk button times what your grades were that you entered, like that.
Okay, and then add them all up.
Good. And you're good with the like the drag and the sum thing, right?
Yep.
Good. Good. That's it. Oh, I suppose. Questions 1 and 2 for 4, 5. I think we. Oh, that's stem and leaf plot, and that's the stuff from 4, 4. Hang on. Let me first fix the. Um, so do you remember what a stem and leaf plot is? I guess is the question. I've got too many windows open here. Um, okay, cool. Bless us. I mean, I'm happy to talk more about it. But I'm glad you remember. What I'm doing is making sure that we have multiple attempts for the lesson checks, and then we'll make sure we answer the lesson check. I believe the answer is 149,777.78, but I could be wrong. Okay, so let's do lesson check. Let me share my screen. I had to stop sharing because I didn't want you to accidentally see grades. Here's 4.5 lesson check. And that is answer question 6 on page 450. Find the median salary. Yes, we already did that. That is the 5, not the X bar, median salary, 53,000. No, is that which one is it? Question 6. It's the one without Newman's salary, so it's the 52,500. That's our answer, 52,500. Let's make sure I'm right. Hooray! Okay, so let's talk about, there we go, measures of spread. Feel free, if you're still stuck on this wild question, feel free to come back, bring some more questions on Wednesday, and then also see how it goes with stem and leaf plot. Maybe ignore this 9 classes and make your stems 9 through, well, maybe 9 is okay. And then your group frequency is you're going to use your stems. So see if you can't put that together. If you get stuck, let's talk about it um, uh, on Wednesday. So what we've looked at here in 4.5 is those measures of central tendency. So what's the center value? What's the most common value? You hear it in the news all the time. Um, the median salary or the average salary of an American is such and thus, or the average gas price is this or that. And it's used to just kind of talk about what's the state of these prices or these incomes in a way to generalize topics about lots of people. So there's another important measurement in statistics that goes with the measure of central tendency that helps us understand our data set. And that's the measures of variation. Another word for this that we use a lot in our stats class, our 133 class, is the word measures of spread. So we can talk about like what's the center, and then we can say how spread out are all these data values. And we often think about how spread out are the data values relative to the center value. So our way to attack this problem is take a look at these two pictures of these two pictures of groups of dogs. So these dogs are all about the same size, right? And these dogs are kind of big and small. So there's a varied amount. One of the first and simplest measures, which is close, super close to the mid-range, is called the range. And it's just the largest number minus the smallest number. Now, I am just a huge proponent of technology, so I think we should immediately go to Desmos, and we should enter these two data values into Desmos, or these two data sets into Desmos. So we'll call A the first picture. Remember, you want your square brackets. That's the 70, 73, 58, 60. And B will be the second picture of dogs, and that's the 30, 85, 40, 125, 42, 75, 60, and 55. Okay. As you recall, maybe from before, we already know how to calculate the largest and smallest value. So we're just going to do maximum of A minus the minimum of A, and there it's 15. So they're 15 pounds apart in terms of weight. And then we're going to do the same thing, but with B. And there they're 95 pounds apart. So we could see that the weights of these dogs are, when we compare the maximums and minimums, when we compare the ranges, they're quite spread out. There's a total of 15 pounds in between. There's a total of 95 pounds in between. Now, our author also told us to calculate the mean of each, and look at that. Notice the means are very similar. So the measure of center for each of these is almost exactly the same, 64 pounds or 65.25 pounds. But the range or the spread is quite different. And it should be obvious, like when we look at the two pictures, like it's, oh, duh, like we've got a really heavy dog here, and we've got a really light dog here. Or maybe this is the lightest dog. Whereas here, these are all fairly heavy dogs. Okay, so this is another important concept that we talked about with the mean and the median. Why is the range limited? It uses potential outliers in its calculations. Let's say in the calculation. And that means it might not be a good measurement of the spread. Just like the mean, if there's outliers in the data set, the mean isn't a very good measure of spread because the outliers have a huge effect on the calculation. So we use the median. Okay. The other thing is it only looks at two data values, right? It only looks at the biggest and the smallest. What about all the numbers in between? So we've got to have another measurement, and we do. It's called the standard deviation. Standard deviation is a little bit complicated. We are not going to do this by hand at all. Desmos and Excel will do this for us, but I do want you to understand the definition of what it is. It's and the generally or the general understanding of standard deviation. It's the average distance each data value is away from the mean. So remember, average is like a mean, median, or mode, right? So what we're doing is we're adding up all the distances that each number is from that center number or that mean number, and figuring out and adding that up and dividing by how many. This is only true. So this is only a good measure if there aren't outliers. And there's another key thing, another key concept if it's a normal distribution, which we're going to learn about in 4.7. But for now, let's understand how to get standard deviation. This is a great thing for your reference sheet. A standard deviation that's large relative to the mean tells us that the data values vary pretty widely from the mean, meaning they're quite spread out. If it's relatively small, that means they're all kind of close together. There are two flavors. There's population standard deviation and sample standard deviation. And they are different numbers because they are different calculations. So we use S for sample standard deviation, and we use sigma for population standard deviation. That's a little Greek symbol. Notice the only thing different between the two formulas is that we're dividing by a slightly different number. X bar, remember, is sample mean, and mu is population mean. And the calculator doesn't know the difference between a sample or a population mean in a data set. It's up to us to know what we entered into the calculator, whether we're working with a mean or whether we're working with a population or a sample. Most often, you're going to be working with population values. The weird thing is that Alex treats most data sets as populations. So let me show you how to calculate these standard deviations in StatCrunch. StatCrunch, I'm sorry, I'm talking about Desmos. So in Desmos, under the statistics part, there's an stdev. Oops. I need to do it here. There's an stdev. That's sample standard deviation. And there's an stdevp. That's population standard deviation. Okay. So in Desmos, stdev, sample standard deviation. In other words, S. And then sigma is stdevp. It's population standard deviation. So for those dogs, I'm going to put an A for each of these. There's the two different standard deviations. And here's for the second data set. And there's their two standard deviations. So you can see the picture of the dogs that are all basically the same weight. Their standard deviation is quite small. These are samples because those are not all dogs. So the correct measurement would be the larger one, the stdev. And for the other picture where there was kind of a wider variety of sized dogs, it would be 30. Now, if we compare that to their means, here, let me get rid of the population ones. you can see that relative to the mean, the group A has a relatively small standard deviation, and group B is like half of the standard deviation. Which leads us to the best measurement of spread, and that's called the coefficient of variation. It's this is very similar in name to what we did in Unit 2, which was the correlation coefficient, which was R. Remember, that value told us whether the linear or exponential model was the most appropriate model for the data set. Don't confuse that here. Coefficient of variation is really this. It's the mean, it's the standard deviation divided by the mean. Now, if we're working with a sample data set, we'd use the sample standard deviation divided by the mean. If it's a population data set we're working with, we'd use the population divided by the mean, the sigma. So you need to be careful. You have to keep track of which one are you using, stdev or stdevp. For our problem, if we want to calculate the coefficient of variation for each of them, we can just take these values, stdev A, and divide it by mean A. There is the coefficient of variation for the first picture of the dogs. Here's the second one. And what this is, it's literally, this sentence is a really good sentence. Oops. It is literally the percent of the mean the standard deviation is. Okay, so we can multiply this by 100, and we can say 11.28% of the mean is the standard deviation, and we can multiply this one by 100, and we could say 47.96% of the mean is standard deviation. The closer these values are to 1 or greater than 1, the more spread out these things are. So 47% is quite spread out. Even 11% is fairly spread out. And that just means that there's a lot of variance, a lot of difference between the data values. They're not clumped together. All right, that's a lot. I want to see how it's settling with you. So go to your worksheet and let's do these calculations. Let's see if I can find which worksheet it should be, though. I guess I closed it. Oh, it's over here. It's over here. Okay, so go to your 4.6 worksheet, and I believe, yes, this table of values is still the same data set that we used before. So if you deleted it or whatever, I will dump in chat the data set again. Here it is. That will reopen, I believe. Let's see, does it reopen? That reopens just the table. You may want to again state it as like A equals or something like that. And you are to calculate oops. You're to calculate the mean, the range, the standard deviation, and the coefficient of variation. Okay, so let me give you 5 minutes to put that together. Set a timer for 5 minutes. How are we doing, y'all? You feeling like you're getting this or not so much? Does this look like what y'all got? Nice. So now we're going to talk about how the spending. So then your job is to talk about kind of like what have these, how has the government spent money on defense over these years? And you're supposed to note that these aren't listed in chronological order. They're listed from least amount of spending to highest amount of spending. You could go in the Excel file for project 2 if you wanted to see for what years were these the spending. But what you're going to talk about is kind of like how spread out these appear to be. You're looking at the fact that 36% of the mean is the standard deviation, so that's a fairly high spread. So some comments you could make is that the spending on what is this on the Justice Department has varied pretty widely over these years from 93 to 2014, these 22 years. That kind of the average spending was the 22,000. The range of spending is at 22,000 or 21,000 million, right? Like it's a kind of a that's the stuff I'm looking for in your description there. Okay, so that was a really fast look at 4.6. And we've really hit the highlights. But one of the things is that I want to make sure you get is what does the standard deviation really tell us about her? Like, how do we understand it? So let's take a look at these 3 questions. We're going to identify the data set. I'm going to ignore number 6. Forget that. We're just going to calculate it. For 6 and 7, we're going to think about which one of these 2 would have the higher or the larger standard deviation. So the first data set is the 40-yard dash times for starting running backs in the NFL. And the second one is the 40-yard dash times for every student in our math class. So what do y'all think? Which one is going to be more varied in the data values? Which one will have the larger standard deviation? Why the students in our math class? Totally agree, but why? Right. Really? Are we not runners? So Jennifer sent the message just to me, not to everyone. Right. The idea here is that students in a math class, like you're not, your job is not to run fast. I am not a fast runner. I do some running, but it's more long distance. Whereas running backs in the NFL, their job is to run fast, right? So these guys are all going to have roughly the same running times. There'll be a little bit of variation, but it's going to be fast. Whereas for us, who may or may not be athletes, we're not all guaranteed to be athletes. Those numbers are going to be kind of all over the place. So they're going to be very spread out, which means 2 would have the higher standard or the larger standard deviation. Good. Okay, what about 8? Average monthly high temperature in Chicago, average monthly high temperature in Los Angeles. Right. So Chicago has summer and winter. Like right now, the average high might be in the 20s, whereas in Los Angeles, the average high might be in the 70s. And then, like Chicago, it might fluctuate between the 20s and the hundreds, whereas Los Angeles might fluctuate between the 70s and the hundreds. Um, so again, data set one. Good. Okay. I like this question too. So here we got a professor has two sections of a math class. We got an 8:30 a.m. class and the mean score, so we'll call that the X bar, is 74%, with the standard deviation is 3.6%. And then the 2 p.m. class has a mean score of what? The same thing, 74%, with a sample standard deviation of 19.2%. So which class do you want to be in and why? Ignoring the times, right? Because we'd all rather be in the 2 p.m. class than the 8:30 a.m. class because of the morning section, right? So there is no right or wrong answer. Like what does the small standard deviation tell us about most of the scores of the 8:30 a.m. class? Like what's happening with those students? Good, it's more consistent and it's mostly in the 70s, right? So no, in this 8:30 a.m. class, like there's probably no 4.0s. They're all consistent, but they're super low, not particularly high. Whereas this class, um, it's super spread out. So there's some 4.0s and maybe some 0.0s. I've seen students talk about this that say, "Oh, I want to be in class 2 because I'm a good student, so my score would be the high. I would have the 4.0." I've had other students say, "Ooh, this is a bad instructor," although it is the same instructor, so presumably there's no difference in how instruction is done. If it was two different instructors, you might prefer this class because it seems like students across our understanding across the board is the same. Okay, let's talk about this project. Oh wait, no, let's do the 4-6 lesson check. So the 4-6 lesson check says what data set is likely to have a larger standard deviation. That's the one we just did. I believe that is, let's see, it's question 7. So it's this one, data set 2. Data set 2. All right. Okay, so I put in the rest of the data yesterday that you need for the project. So there's the salaries data. These two other things that you need, this misleading graphs and the whole milk data, we'll learn about in class on Wednesday. But for now, we can do the rest of the project. So let me download this and we'll kind of talk through how you can finish this project. So on Wednesday of last week, we talked about the sampling method. I'm assuming you have created that. The 4.5 lesson check was the 53,000. Or was it the 52,500? Maybe it was the 52,500. I think it's still there. Yeah, it was the 52,500. You are most welcome. So we talked about how to generate the sample. So that should be done. And now we're going to calculate the measures of average and the measures of variation, and then you're going to tell me which one is which based on your sample, and then you're going to do it for a population. So we need this downloaded, and you can do it all in here. So it's kind of nice to, it would be nice to format it. Maybe you have your sample. Note that in the project, you have to describe how you got your sample. So make sure you're leaving some space somewhere to talk about it. I believe it says you had to have what, 25 data values. So this is how I make sure I count. There's my 25 data values as a sample. So then I might label something like measures of average, and then list those measures. So mean, median, median, mode, and mid-range. And then we'll get those listed here. And then next to that is measures of a variation or spread. And those are standard deviation, range, and coefficient of variation. Excuse me. Okay, now note that you're doing this twice, right? So if we look at the project, you're doing this for a sample. So measures of average for the sample, and then measures of variation for your sample. And then you're going to repeat that for population values of average and variation. Okay. So for the sample, you're just doing the 25 ones that you generate using one of the sampling methods you learned about from 4.4. And then for the population, you're using all 133 data values. So I really encourage you to make sure you know how to do this in Excel, because you don't want to have to type in these data values in Desmos. That's just super tedious and not worth your time. So I'm doing here sample, and then like below I could do, whoops, population, and then just copy this all again, and here we go. Okay, so to get the mean in the sample mean in Excel, you would just do equals and you would type average. And your job then would be to select all the 25 values in your sample. And this would get you your sample mean. To get the median, you hit equals, you type median, there's your median function. Select your sample, that's those 25 values, and there's your median. To get the mode, you just type equals, you type mode, and you want to do multi, which means there could be repeat modes. That's possible, and that could very likely happen with your sampling. If it gives you this not a, in/a, that means there is no mode because there's no repeated values. And then remember, mid-range is the maximum. So there's a maximum function. So we just do max of the sample minus the minimum of your sample. Notice I'm selecting all of the values, and I don't have all mine in there. I didn't create my sample, divided by 2. And please note, it is not minus for mid-range, it is plus. There's all my measures of sample. That's how you calculate it in Excel. For the measures of variation, to do standard deviation, you hit equals and you start typing stdev. Notice there's 2. stdev.p, that's for population. Since we're doing a sample on the first one, you do stdev.s, select your sample, and there's your calculation. Range, remember that's the maximum value. So I'm selecting those same cells minus the minimum value. Here's my range. And then remember that coefficient of variation is the standard deviation divided by the mean. There they all are. You then do the same thing for the population, but instead, you're taking all of the data values. So one of the things you can do is you can delete this thing, and notice it's column B. So you could do equals mean, and when you or sorry, average, and when you do this, you can select that column. Oh, no. I guess we have to hang on. We have to unmerge this, and we could just say this is equal average and select column B. But don't look at that. Oh, I might have given you the answer. You just have to make sure you select all of the values here and that's the population. Now, remember, when you calculate the standard deviation, you have to choose the stdev.p because this is the population value versus the sample value. Any questions on this? Okay, some careful things you need to note. So those are all the calculations. You then need to give me some intelligent thoughts about what do these calculations suggest about the average salary of a Jackson College employee. And then which is the best measure, mean, median, mode, or mid-range, and explain why you chose that. Remember, you need to talk about outliers. Same thing for variation. You're doing that for the sample. And then notice you're doing these calculations for population. You need to do the correct symbols for each measure. There's only two, mean and standard deviation. That's X bar and mu versus S and sigma. And then you need to talk about how close are your sample values to the population values, which is a measurement of how accurate your sampling method was. And then talk about, would there be a different sampling method that would be more accurate? And then thinking about, hey, what if you wanted to know the average salary of someone working in America? How would you do that? So you have what you need to do task 1 and 2 now. And I've basically done most of that work. I've shown you how to do that in Excel. And please use Excel to do it. You then have 2 more tasks. Task 3 is 4.7. So we'll be talking about that on Wednesday. And task 4 is 4.9. We will also be talking about that on Wednesday. And then we will be done with this semester. Your job is just to prep for the final and finish up any of these 2 things. And my job is to get grading and get everything done. So what questions do you all have for me? All right, y'all, take off. We'll see you on Wednesday. If you have no questions, I'll hang out and answer any. If you have any, show up, come up.